Hi. This week we're doing the skeletal and muscular systems. In retrospect, last week we were doing a general introduction to all human body systems. We're doing the skeletal and muscular systems first this week in a little bit more detail. The essential question that we have for this week is, how do your skeletal and muscular systems work together? I hope you enjoy this presentation. So the overview for this week um, will span three different topics. First, the skeletal system, then the muscular system, and then we're going to talk about injury, disease, and exercise to both the skeletal and muscular systems. What I need you to know, and so your prerequisite knowledge, is what are the levels of organization in your body. And remember, when we discussed the levels of organization in our bodies, we discussed how the smallest functioning unit in our body would be a cell. And a group of cells a group of similar cells would create a tissue, and a group of similar tissues would create an organ, and similar organs create an organ system. We also have the functions of major human body systems, which we discussed last week, so make sure that you review those before starting this lesson. And finally, how do the human body systems work together to maintain homeostasis? And this was the main stake of last week's lesson. Not one body system can survive on its own, and hence they all work together. And to maintain the stable internal environment in our body, which is what homeostasis is, they all need to be working together. And we gave an example how the brain and the integumentary system work together to lower your body temperature, for example, when it's very hot outside, by causing your skin to sweat. Okay, so this is what the skeletal system is. This picture or photo is courtesy of Alex Gray. I thought this skeleton was pretty interesting because in anatomy and human anatomy in general, it's very important to look how things are postured and how things look like. And as you can see, this skeleton has his arms by his side and his palms are facing outside. Okay, this is very important when we discuss muscles and the different group of muscles, and what are they called, and what is a function of one group as opposed to the other group. And here I'm talking about flexors and extensors, but we're going to discuss these briefly, in more detail in the video to come. Okay, so what are the functions of the skeletal system? Now, the skeletal system is the organ system that supports and protects your body, and hence it allows it to move. People have a very interesting idea about bones. They think that bones are not alive. Maybe because when people die and they get buried, the only thing left is the bones, and maybe that's what gives people the idea that bones are not really living, but actually they are. They're composed of living cells called osteocytes and osteoblasts, and they have everything that any living organ in your body has. So it has its blood supply, it has its nerve supply, it needs nutrients, it gets rid of its waste. So your skeletal system is pretty much alive. Our skeletal system, like the one, and this is the same system that exists in most mammals, is inside our body. Now, some animals like crustaceans have their skeleton on the outside, like crabs and lobsters, but we don't. Ours is inside our body, and because it's inside, we call it the endoskeleton. And remember, the prefix endo means inside. So it's very important to know that our skeletal system in human beings is an endoskeleton, not an exoskeleton like crustaceans, for example. So the four main functions, and we briefly talked about them and touched base with these, are: it stores minerals, it produces blood cells, it provides protection for our internal organs, and it provides support for our bodies, and it makes it possible for you to stand, to sit, and so on. Now, what kind of minerals does your skeletal system store? It stores calcium, and the part of your bone that stores the calcium is called the compact bone. I'm going to show you the compact bone in a slide to come. Also, where do your blood cells get produced? And this might be a little bit difficult to grasp, but inside our bones, we have a part called the bone marrow, and the bone marrow's main function is to produce red blood cells. So, very important question. How does our skeletal system allow our body to move around? I mean, the skeleton is a skeleton at the end of the day, and everyone would think that moving around is the job of muscles, not the job of skeletons. Well, yes, this is partly correct, but our skeletal system provides our muscles for a place to attach. So, if our muscles have nowhere to hold on to, then any movement made by the muscles will not be any movement at all. And hence, because of the attachment sites on our bones, the muscles are able to pull on the bone, and obviously this causes movement. Now, a very important thing about the skeletal system in general, it's divided into two different parts. A skeleton called the axial skeleton, and another one called the appendicular skeleton. And I'll show you in this picture. Here we have the axial skeleton. This skeleton is in our midline, or this part of our skeleton's in the midline. It comprises of our skull, our vertebrae, and of course our rib cage. We have the appendicular skeleton, which involves the rest of our skeleton. And now we have here, some of the bones that we have are our shoulder, our arms, our pelvis, and of course our legs. Now this is a picture of the bone that I wanted to tell you about. This includes most of the parts that we're going to be discussing later. Now, one of the reasons why we say that bones are alive, because they initially actually have blood vessels going in and out of them. We also have something called ligaments, and ligaments are very important. They're tough and they're flexible strands of connective tissue. Their job is to hold bones together. Now, if we didn't have ligaments, our bones wouldn't really be attached to each other. We have something very important called cartilage, and cartilage is also very strong, very flexible, but smooth. And we find these at the end of the bones. So we have cartilage here, and by the way, this is a femur, which is the bone in your thigh. So we'd have the cartilage here at both ends of the bone. Its job is for the bones to move smoothly, and by that, bones are generally attached to each other, and we don't want them to be rubbing against each other while any movement's going on. So this is a very good substitute for a lubricant that we have in our body. We have a section here that is called the compact bone, and it's a very thin section. It's the outer section of any bone. This part is where minerals, especially calcium, are essentially stored. It's very hard, and it has no visible open spaces. So when you look into the compact bone section, it has no spaces. Underneath the compact bone, we have something called the spongy bone. And the spongy bone is quite the opposite. It has a lot of spaces inside. It is the main strength and support portion of your bone. The open spaces houses the bone marrow, and this is where the red blood cells are being made. And as you can see here in the spongy bone part, we have red spaces in between. So this is where the red bone marrow is that makes the red blood cells. We also have another type of marrow called the yellow marrow. Yellow marrow is where is in the center, and it's where our bones store fat. So inside our bones, we have two things that we didn't generally think we had. We have a factory that makes the red blood cells, and we also have fat storage inside our bone. All the connective tissue in our bone is made of a protein that is called collagen, and collagen allows our bones to be slightly flexible. Now, flexible in bones is good. If our bones were purely hard, I want you to think of a piece of chalk, like the ones we use on blackboards. Now, chalks are very, very hard, but because they contain nothing that allows flexibility, if you drop a piece of chalk on the floor, it breaks into pieces. And the same would happen to our bones. If our bones didn't have a spongy portion, if they were just completely made out of compact bone, then our bones would easily shatter. And so it's very important to have connective tissue that is made out of collagen that gives flexibility to our bone. So how do our bones grow? Babies have cartilage that is later replaced by bone. And I want you to have a look at this part. We call this part a growth plate. And a growth plate is where our bones lengthen in size. Inside our growth plate, we have cells that are called osteocytes, and osteocytes generally deposit bone tissue, and that's how we grow. Now, these growth plates disappear You know, by the age of about 21, most growth plates in our bodies would disappear. Okay. How are bones connected? Now, we said that our bones are connected to each other because of ligaments, but what is another support for our bones? We have something called joints, and a joint is basically a place where two or more bones connect to each other. We have two main types of joints. We have fixed joints, and the fixed joints we have in our skull, and they really don't allow any movement between the bones. And we have movable joints that allow movements of bones, just like the ones we have here. Now, of course, there are way many more joints. You know, for example, our vertebrae, each vertebra has a joint between it and the one above it or below it. But, you know, the highlighted ones here in red are mainly the joints that do most of the movement in our body. First type of joint, very important, ball and socket joint. And the reason why they call it ball and socket is because, for example, here, this is our shoulder joint, and the upper end of this bone, which is called the humerus, looks like a ball, and the part in the shoulder where it attaches kind of looks like a socket that it goes in, and hence the name. Ball and socket joints allow one of the bones to rotate in a large circle. So if you would move your shoulder around, so you know, if you stretch your arms out wide and you move them in circles, you'd realize that this joint in particular allows way more movement than some of the other joints that we're going to be discussing. Another type of joint would be the gliding joints. They allow flexibility in our wrists and ankles. Now, they're not perfectly, they don't give you a perfect movement, maybe like your shoulder joint, but they still allow quite a lot of different movements. And the flexibility here is also because of the different types of the different bones that we have here and the different attachments to the bones. But here, this is essentially where the gliding joint is. A third type of joint is called a hinge joint, and they call it hinge joint because they're like the hinges that we have on a door. They only have two movements, nothing more. So we find these in our knees and our elbows. They are hinge joints, and they just like your knee, just allows movement in this direction and this direction. That's it. Okay. This is a very interesting part, the injuries and disorders that we have in our skeletal system. The first one I want to discuss with you are fractures. A fracture is basically a bone that is broken, and if we look at this picture here, we have this is your forearm, and these are the two bones of your forearm, and one of them here is actually broken, and see that highlighted part, the red highlight over here is where the fracture is. This isn't a real X-ray. This is an animated one, but I thought it depicts fractures pretty well. A second injury or disorder of our system is something called a sprain. Now, we experience that a lot, especially when we're running around. A lot of us twist their ankles, and that's what basically happens. Now, this bone, this long bone here, is called a fibula. A fibula is attached to your ankle bones over here by a ligament. Now, when this ligament is stretched a little bit too far, okay, this is what a sprain is. Okay, it's stretching a ligament a little bit too far. This is very painful. It causes your ankle to swell, and one of the best things to do as soon as you get a sprain is to put a pack of ice on that area to try and minimize the swelling that's going to occur. Osteoporosis. Now, it's not really a disease that we need to worry about at our age at the moment. This disease is generally characterized to manifest in people of an older age. I want you to look at these two pictures. They're very different. The one on the left here is what normal bones look like on the inside, and this is what a diseased bone looks like on the inside. Now, the one on the right is a bone or is a piece of bone that had osteoporosis. And if you realize here that the spaces between, in the spongy part of the bone are much bigger in someone who has osteoporosis than someone who's normal. So the bone essentially becomes very thin, becomes very weak, and it's more liable to fracture very easily. And this is a problem that a lot of old people have. Should they have osteoporosis, their bones break easily, and one of the problems of old age is that once your bones break easily, it's a little bit difficult for them to mend quickly. So it's a bit of a problem here. And finally, another disease of our skeletal system is something called arthritis. Arthritis is a disease that causes joints to become very stiff. They might swell up, and they're definitely very painful. And again, here in this picture, we have two hands. The hand on the left is a normal hand. There's nothing wrong with it. And the one on the right is one that has arthritis. As you can see, the bone, the joints that are arthritic are cracked. Because the picture here shows them as being red. Red generally means inflammation, so they're probably inflamed. Very, very painful condition. The problem with arthritis is that after some time, arthritic joints, their shape changes. So instead of your fingers looking long and slender, no, they start to bend at the joints, and that's why we say they're misshapen. Well, I hope you've enjoyed the first part of this week's lesson, and encourage you to watch the next video. We're going to be discussing the muscular system in more detail. How, what is a muscle, what are the different types of muscles, what are the muscle pairs and tendons, and I'm also going to explain how bones and muscles work together.